Hello, in this video we're going to be working Algebra 2 Homework 4.4, which is more practice on quadratic equations, this time focused on intercept form. But the first couple of questions, it's going to ask us to write an equation of the parabola in vertex form. So we're going to just fill in vertex form so we can use that for a reference. If you need to go look at your notes, that might have been something you did. That's y equals some number a times x minus h squared plus k, where h and k are the coordinates of the vertex and a is the leading coefficient. Okay, so if we've got a parabola that passes through the point 4, -7, has vertex 1 and -6, we're going to start off kind of with that skeleton. Y equals some number times x minus, okay, we've got the coordinates of the vertex, so x minus 1 squared minus 6. Okay, we can just plug in h and k. And now we're going to use the point 4 and -7 to find the value of a. Okay, so I'm going to go over here, I'm going to use x equals 4 and y equals -7. Okay, so x is 4 minus 1 squared minus 6. Okay, so I'm going to add 6 to both sides to start trying to solve for a. I guess I could also do 4 minus 1 squared. But I'm going to add 6, and I'll have -1 is equal to a times 3 is 9. Okay. And then I can solve for a by dividing both sides by 9. And then I've got myself an equation. I could just go in there and put in -1/9. That'd be great. Alright, the second one is going to be pretty much exactly the same, right? So we're going to start off with kind of our skeleton equation. Y equals a times x minus h squared plus k. And then we'll just kind of plug in what we know. Okay, the vertex is -2 and 5. So x minus -2 minus 5. Or no, plus 5. Because the y coordinate's +5. And then we're going to solve for a by plugging in the other point. So y is equal to 5 when x is -4. 5 is going to be a times -4 plus 2 squared plus 5. Okay, so 5 will equal, oh no, I don't know what to do here. 4a plus 5. Oh, I plugged in, okay. Y is -4 and x is 5. Okay, that makes more sense. Okay. Okay, and then -4 will equal a times 49. Okay. Plus 5. And then I will subtract 5 from both sides. No, this will be -9. It's equal to 49a, and a is, I guess, -9 over 49, okay. So then I'm going to just plug in that value right here, and I'll have y equals -9 over 49 times x plus 2 squared, and then plus 5. Right, this last one on this page, okay, it's again the same type of problem, so I'll approach it the same way. Start with skeleton. Plug in the values I know. Okay, I've got h equals -1 and k equals -1. So x minus -1 squared minus 1. Okay. Then I'm going to plug in my x and y to find a. So y is equal to 2. That'll be equal to a times 2 plus 1 squared minus 1. Okay. So I've got 2 is equal to 9a minus 1. Add 1 to both sides. Divide both sides by 9. I get 3/9, which is 1/3. Okay, and then I can go back up here and write that in there. And I've got myself a vertex form equation. The next page looks like we got some intercept form problems. So okay, we need to remember that intercept form is y equals some number times x minus p times x minus q, where p and q are the zeros. They're the x-intercepts. Okay, so we've got x-intercepts at 12 and 8, and it's passing through this other point. So we're just going to really approach this the same way. Start with the skeleton of the intercept form equation. And we'll plug in what we know. Okay, x-intercepts are 12 and 8, so I'll put those in there. And then use that 0.9 and 5 to solve for the unknown, which is a. So I'm going to say y is equal to 5 when x is 9. So a times 9 minus 12 times 9 minus 8. I'll divide both sides by -3, and I'll get a is -5/3. I can plug that in, and I'll have my intercept form equation. Alright, again, pretty much the same problem. So I'm going to start with my skeleton equation. Plug in my x-intercepts, so -7 and -1. So x minus -7 and x minus -1. Then if it's going to pass through the point 1 and 1, 1 equals a times 1 plus 7 is 8 times 1 plus 1 is 2. So that's going to equal 16a, and a will be 1/16. This one, I'm going to say y is equal to some number times x minus p times x minus q, where p and q are going to be -9 and 9. And then if it passes through the point 0 and 4, 4 equals a times 0 plus 9 times 0 minus 9. Okay. And then I'll divide both sides by -81. I'll get a is equal to -4 over 81. So it's got some weird numbers on it. Okay. Alright, on the next page we got one of these. Write a quadratic function that passes through these 3 points. Okay, so we know that's going to be we're going to have to set up and solve a system. We can do that. We're going to say, alright, I'm going for y equals ax squared plus bx plus c. Okay, we've got the points 0 and 1, 2 and -1, and 3 and -8. Alright, so each of these points is going to give me an equation. So when I plug in x equals 0 and y equals 1, I'll get 1 equals a times 0 squared is 0, plus b times 0 plus c. Okay, that's telling me that c needs to equal 1. And I'm going to start using that, like immediately when I start writing the second and third equations. So when I plug in x equals 2 and y equals -1, I'll have y equals -1, a times 2 squared, plus b times 2, plus c, which I now know is 1. So, okay, and then from the third point, I'll write a third equation. Y is -8 when x is 3. So a times 3 squared plus b times 3 plus c, which is 1. Okay, now the system I'm working with that I need to solve is, I guess if I subtract 1 from both sides, I can just make it as easy on myself as possible. I have 4a plus 2b equals -2. And then if I subtracted 1 from both sides of this one, I'd have 9a plus 3b equaling -9. Alright, now I think, I'm going to multiply the first equation by 3/2, by 1.5. Multiply everything by 1.5, or I guess negative 1.5. That will allow me to eliminate b, and I don't think that's too much. So I'm going to multiply 4a by 1.5. So 4 times 1.5 would be 6. So negative 6a minus 3b equals negative 2 times 1.5 would be negative 3, or positive 3. And then I'll have 9a plus 3b equals negative 9. I'm going to add these equations together, and I'll get 3a equals negative 6. Okay, so that means a needs to equal negative 2. And I should have some sort of equation that'll be easy enough to work with. Oh yeah, I'll take this one right here. I'll take this down and use it to find the value of b. So 4a will be negative 8 plus 2b equals negative 2. I'll add 8. 2b equals 6, and that tells me b equals 3. Okay, so now I'm going to go in over here, and I'm going to say, all right, it's ax squared. A was negative 2 plus bx, and b was 3. And then c was equal to 1. Okay, and that was us writing an equation for a parabola that passed through 3 given points. Alright, now we've got a graphing type problem with a laundry list of trivia questions, which normally these aren't exactly my cup of tea, but I do like this one. I like where this one's headed. So f of x equals 1/4 of x minus 6 times x minus 2. Okay, we're going to start by, I think, plotting the zeros as it would suggest here. So the x-intercepts are x equals 6 and x equals 2, because it's any time 1/4 equals 0, well, that doesn't contribute anything, because 1/4 is never 0. Anytime x minus 6 is equal to 0, or anytime x minus 2 is equal to 0. Okay, so that'd be where x is 6, or maybe where x is 2. So I'm going to plot those. X equals 2, 3, 4, 5, x equals 6. All right, axis of symmetry. Okay, if we've got these 2 points and we know that the parabola is symmetric, then we know that the axis of symmetry is going to be halfway in between them. So it's going to be, that's right here. Maybe I'll color that in green. That's where x equals 4. Opens up or down? Well, it's going to open up because of the positive 1/4. All right. Because it opens up, it's going to have a minimum, right there, at x equals 4, okay, right at the x coordinate of the vertex, which happens to be on the axis of symmetry, with a value of, I don't know, we're going to have to find that out. Maybe go over to the side here and say, when x equals 4, f of 4 is equal to 1/4 of 4 minus 6 times 4 minus 2. And that's going to be negative 1. Okay, so f of 4 equals negative 1. We've got a point here. And, alright, I guess that's... Hold on, let me think about this. Oh no, that does make sense. Okay, so the minimum value is negative 1. Okay, the vertex, we just found it. That's 4 and negative 1. Okay, and then the focus and directrix stuff, maybe I'll find after I go ahead and sketch this. Maybe I'll put another point on here. I'll see what's happening with this when x is, I don't know, right here. I don't even know what this is. So it would be x is 4, 5, 6, 7, 8. All right, let's see what f of 8 is. Maybe I'll plot that one in red. F of 8 equals 1/4 of x minus 6 times x minus 2. Okay, so that's 1/4 of 12. Oh, that worked out well. That's equal to 3. Okay, so I'm here. And, because of the symmetry of the parabola, I also know that f of, if I went 4 to the right of x equals 4, I could go 4 to the left of x equals 4 and be at the same y value. So that would be f of 0 is also going to equal 3. And we can see that, yeah, it's positive 12 divided by 4 is positive 3. I think this is good enough for us to make a really nice sketch of the parabola. Yeah, that was good. Okay, and then the focus and directrix. I'm going to need some more room, I guess. Maybe I'll just get some of this out of the way, because I don't really need that anymore. I don't know. And I can pick up over here and do some work to find the focus and directrix. It's 1 over 4p. And that's telling me that p needs to equal 1. Okay, so I know that I need to go up 1 unit from the vertex to get to the focus, because the focus is on the inside of the parabola. Okay, so I can see that the coordinates of that are x equals 4 and y equals 0. Okay, in the directrix, I'll go 1 unit down from the vertex, and it'll be this whole line here, the set of all points where y is equal to -2. And I think, yeah, that's all they're asking. Alright, here if we're looking at a picture of the parabola, I mean, this is pretty much like the problem that gives you the 2 intercepts and another point. It's just giving you a picture of the graph instead of it in words. But we can still work with this, right? We know that we're going for y is equal to some number times x minus p times x minus q. That's going to eventually be our answer. And so we know that p and q are numbers we're going to get from right here. It's x equals -1, and right there, that's x equals 7. Okay, so we're going to replace p and q with -1 and 7. -1 and 7. All right, and then we also know that the point is this 5 and 3 is on the graph. Okay, so I'm going to plug in x equals 5 and y equals 3 to solve for a. 5 plus 1 is 6, and 5 minus 7 is -2. So I've got 3 equals -12a, and a will be -1/4, because 3 divided by -12, yeah, that's the same as -1/4. And I'm going to plug that in there. I'll say y is -1/4 of x plus 1 times x minus 7. This one, oh man, I meant to replace that one, and I am just now seeing that it is a sideways parabola. Okay, well, what I'll tell you is, you don't have to do that this year in this class. This is not something that's specifically in Texas Algebra 2. It's in Texas Pre-Cal. So this is something you'll deal with next year in Pre-Cal. Hopefully, maybe in my AP Pre-Cal class. But yeah, I think I'm just going to show you how you would do it. Anyway, okay. So the vertex form equation for a sideways parabola is x equals some number times y minus k squared plus h. Okay, and it's pretty much exactly the same, where a is equal to 1 over 4p, the whole thing. H and k are the coordinates of the vertex. So from over here, I know that, okay, h is looking like 2, and k is 0. So I'm going to replace h and k with 2 and 0. And then I'm going to have to figure out what a is. Okay, and a is going to be 1 over 4p, where p is the distance from the vertex to the directrix, and it's the same as the vertex to the focus. Okay, we don't see the focus, it's going to be like, I don't know, somewhere over here-ish, but we don't need that, right? There's a distance of from the vertex to the directrix. And so I know a is going to equal 1 over 4p, and this is p equaling 4, where p is that distance. So this is equal to 1 over 4 times 4, which is 1/16, and I'll plug that in. So x is equal to 1/16 of y minus 0 squared plus 2. Okay, but I just really want to reiterate sideways parabolas are not going to be on the quiz. They are not going to be on the test. They are not really even part of pre-AP Algebra 2 this year. So that's just all I've got to say about that one. Alright, this next one is the height of a bridge is given by y equals negative 2x times x minus 90, where y is the height of the bridge in yards and x is the number of yards from the base of the bridge. I have a feeling this is going to be like a really steep bridge, but I don't know. Oh, I guess 90 is really far away from 0, so we know that it's, thinking about intercept form, this is like negative 2 times x minus 0 times x minus 90. Okay, so I know that the intercepts of this thing are happening at x equals 0 and x equals 90. And I know that it's a downward facing parabola because it's, got that leading coefficient that's negative 2. So I'm going to draw myself a... Okay. That's going to be my graph. Okay. This will be the first x-intercept, that's at x equals 0. This is going to be the second x-intercept where x is 90. Alright, how far from the base of the bridge does the maximum height occur? Okay, it's going to be halfway in between the two zeros, so that's going to be right here at 45. Okay, so at x equals 45, or something like that. Okay, what is the maximum height of the bridge? Okay, well that's just going to be the y-coordinate that corresponds to x equals 45. So let's say up here, the height of that is y of 45 equals negative 2 times 45 times 45 minus 90 is negative 45. All right, 45 times 45. Oh boy, what do you think about this? Okay, I don't just love doing long arithmetic, so I'm going to do 45 times 45 this way. Okay, I've got 1600 plus 200 plus another 200 plus a 25. All right, 16, 18, 2025. Okay, and if I'm going to multiply that by 2, that's going to be 4,050. 4,050 yards. That's ridiculously high. Okay, so that's probably not a realistic model. I think it probably would have, that negative 2 would have needed to be something much smaller, like some kind of fraction. That's what I was thinking. All right. Oh, another one. That's great. What else we got on this? Okay, we're on problem number 11 out of 20. All right. Well, these all look straightforward enough. We can do these. All right. 3 points defining parabola. So it's going to be y equals ax squared plus bx plus c. We've got 1, 0, 2, 5. And 0, negative 3. I can see that that's going to be the y-intercept, and I know that's going to give me the value of c, so I'm just going to use that one first. Okay, y equals negative 3 equals a times 0 squared plus b times 0 plus c. All right, a times 0, b plus times 0, those are both 0. Okay, so this is telling me c equals negative 3. Okay, and I'm just going to use that when I'm setting up the other two equations. So x equals 1, y equals 0. 0 equals a times 1 plus b times 1. Okay, both of those are 1s because 1 squared is just 1. Plus c, which is minus 3. Okay, so I'm just going to plug that in right now because I already know what c is. And then y equals 5 when x equals 2, so that would be a times 2 squared plus b times 2 plus c, which is, again, minus 3. Okay, I'm going to set up my 2 by 2 system over here, and I'll add 3 to both sides of both equations. So I'll have 3 equaling a plus b, and 8 equaling 4a plus 2b. I feel like I've done this problem already. I wonder if this is the exact same one that was in the notes. Okay, in this case, I'm going to multiply the first equation by negative 2 to eliminate on b. Yeah, this feels really familiar. So negative 6 equals negative 2a minus 2b, and 8 equals 4a plus 2b, and I'll get 2 equals 2a, and no b's. Okay, so a equals 1. Maybe this is slightly different. Okay, and then I've got 3 equals a plus b, so that means b equals 2. I've got c equals negative 3, and so I'm ready to just kind of like plug in all of these. Let's see, y equals 1x squared plus 2x minus 3. Okay, now we're gonna write the equation in intercept form and sketch the graph. Okay, so this is, oh, I thought this said vertex form. Okay, intercept form, we're just going to factor, right? Okay, and we needed some of that. Okay, and these are factorings where the leading coefficient is not 1. This is exactly what we need. So right here for this one, I'm looking for two numbers, m and n, that multiply to negative 7, right? 7 times negative 1. And they need to add to positive 6. Okay, so it's going to be 7 and 1 somehow. Maybe positive 7 and negative 1, yeah. So I'm going to split up that 6x into 7x and minus 1x. Okay, but everything else stays the same. Okay, now I group and factor. I take whatever I can from the first two. That would be 7x. I'd be left with an x and a 1. And then the only thing that the negative x and the negative 1 have in common is the negative, so I might factor out a negative 1. And I'd be left with another x plus 1, right? Because I multiply negative 1 by x to get negative x, and I multiply negative 1 by positive 1 to get negative 1. And then I'm going to factor out the x plus 1. So it would be x plus 1 times 7x minus 1. All right, and that's in intercept form. So I'm going to sketch the graph. Okay, I've got my two zeros. Okay, the first one's going to be over here where x is equal to negative 1, because that would make that first factor equal to 0. For the second one, I need to find out where 7x minus 1 is equal to 0. I'd add 1 to both sides, divide both sides by 7. And that's okay. X equals 1/7. All right, and that's a good sketch. Okay, this next one, we've got y equals 3x squared minus 10x plus 7. Okay, so I'm looking for two numbers that multiply to 3 times 7 and add to 10. Okay, this is going to be adding to negative 10. I think it's going to be negative 7 and negative 3. Okay, so I'm going to split the negative 10x into negative 7x and negative 3x. But if you wanted to split it into negative 3x and negative 7x, that would be just fine too. It'll work out just the same. Okay, 3x squared minus 7x. There's not really much in common to that, just the x. So I'd be left with a 3x and a minus 7. And then negative 3x plus 7, again, there's not much there, but I'm looking to make it agree with this, and I can see that if I factor out a negative 1, I'll be left with 3x and a negative 7. And then that will allow me to factor 3x minus 7 out of this expression right here. We'll be left with 3x minus 7 multiplied by x minus 1. Okay. I've got a parabola, and it's going to open upwards because of this positive 3. And okay, it's going to have 2x intercepts that correspond with, all right, 3x minus 7. Okay, that could equal 0 when 3x equals 7 and x is 7/3. X minus 1 could equal 0, then that would be where x is 1. Okay, 7/3, well, that's bigger than 1, that's bigger than 2, so let's say that's 1, and this is 7/3. Right. This one, we're going to find two numbers that multiply to 60 while adding to 16. That'll be 10 and 6. Okay, so m times n equals 20, m plus n equals 16. I'm thinking, wait, no, not 20. That'd be 20 times 3. Yeah, 10 and 6. But maybe this time I'll put the 6 first. So y is going to be equal to 3x squared. I'll split up the 16x into 6x and 10x. I'll still have minus 20. I'm going to group in factors, so I'm going to factor what I can out of the first two things. So 3x, and I'd be left with an x and a, hold on, I gotta copy that wrong, that's plus 20, and a plus 2. And then on the second 2, I can factor out a 10. I'll be left with an x and a plus 2. Okay, and I'm going to factor out the x plus 2. I'll be left with a 3x and a positive 10. Okay, again, this one has a leading coefficient 3, so I know it's going to open up and be pretty narrow. But you know how narrow or wide a parabola is really just depends on how closely you're looking at it, and how zoomed in or zoomed out you are. So that's why I'm not really too concerned with it when we're sketching. So I can go over here and say, all right, I'm going to have zeros where x plus 2 is equal to 0, or where 3x plus 10 is equal to 0. Okay, so these zeros are pretty close together. So I might draw the x-axis down here and say, all right, negative 10 thirds is more negative than negative 2 because that's bigger, it's more negative than negative 3. So I'll put negative 10 thirds over here and negative 2 over there, and that's going to be my sketch. All right, now this last one, this one's got, okay, I can't just factor out the negative 2 from everything because that 7 is odd. Okay, so I'm going to just use that same AC technique where I'm going to, multiply A times C to find out, negative 2 times 30 to find out what my numbers need to multiply to and find ones that add to negative 7. So I'm looking for two numbers that multiply to negative 2 times 30 while adding to negative 7. All right, and what's that going to be? Oh, okay, 12 and 5 somehow. Okay, so negative 12 and positive 5. So I'm thinking maybe m equals negative 12 and n equals positive 5. All right, so y is equaling negative 2x squared. I'm going to split the negative 7x into negative 12x and positive 5x. And then I'm going to group in factors. So I'm going to factor what I can out of the first two. Definitely a negative 2, but also an x, because both of these two terms here have an x in them. We'll be left with an x and a positive 6, right? Because negative 2x times 6 is negative 12x, yeah. And then 5x plus 30, okay, 30 is divisible by 5, so I can factor out a 5. We'll be left with x plus 6. And then I will factor out that x plus 6. I'll be left with negative 2x plus 5. Okay, use a little more room over here. And so this is going to be a downward facing parabola because the leading coefficient is negative. So I might draw that. It's got 2x intercepts, where x plus 6 equals 0, be x equaling negative 6. Or maybe where negative 2x plus 5 equals 0. Maybe I'll add 2x to this one. And divide by 2. And I'd get a second x-intercept. So put them here. X equals a negative 6 and x equals 5 divided by 2. Alright, just one more page. Okay, same story here. We're going to factor this one. Find two numbers that multiply to negative 10 times 6. It's negative 60. While adding to positive 17? Oh, 20 and 3. Okay, I was thinking 12 and 5 again, and I was like, did I type this up wrong? But no, I'm thinking 20 and 3, so m equals positive 20, n equals negative 3. Yeah, that'll work for us. So I'm going to split this 17x up into positive 20x and negative 3x. I'm going to factor what I can out of the first two expressions. That would be a 10 and an x. And I didn't factor out the negative though, so I'll be left with a negative x plus 2. And then if I factor out, okay, if I need to be left with a negative x plus 2, I'll probably need to factor out just the 3 from negative 3x plus 6, not the negative. Okay, so I'll have plus 3 times a negative x plus 2. Yeah. Okay, now I can factor out the negative x plus 2. Okay, and then I might factor out the negative here and say that's the negative of x minus 2 times 10x plus 3. Okay, and then I know this is a downward facing parabola because of the leading coefficient being negative 10. And, okay, my zeros are going to happen where x equals 2, or where 10x plus 3 is equal to 0. It's looking like that's going to be x equals negative 3/10. So the negative one will be on the left, and the positive one will be on the right. And that's a good sketch. Right. 17, I think factors of, I don't know. I'll be honest, I'm not certain if this technique works for, when it's a fraction. I don't see why it wouldn't though. Okay, I'm going to try it. So I'm looking for two numbers that multiply to half of negative 20 is negative 10, and add to 3. Okay, so it's going to be positive 5 and negative 2. So I'm going to try it, see how it goes. 1/2 x squared. Maybe I'll put the minus 2x here and then the positive 5x after. Okay, yeah, maybe I'll factor out the 1/2 x. Be left with an x, and okay, think about what would I multiply 1/2 x by to get negative 2x? It'd be minus 4. Plus, okay, I'll divide out a 5. I'll have x, and again, minus 4. And then, okay, I'll factor out the x minus 4. Okay. This is going to be a parabola that opens up. It'll be kind of wide because of the 1/2 x squared. And it'll have zeros where x minus 4 is equal to 0, or where 1/2 x plus 5 is equal to 0. Okay, I'll multiply both sides by 2 here and get x equals negative 10. And x equals not 0, and that doesn't make any sense. If x minus 4 equals 0, then x is going to need to equal 4. That was a good collection of factoring practice problems. Alright, what is the axis of symmetry of the parabola defined by the equation 1/2 of x plus 3 times x minus 10? Alright, so we know that this thing is going to have zeros where x is negative 3 and positive 10. Right, because if x is negative 3, x plus 3 equals 0. And if x is 10, then x minus 10, you can't. Oh yeah, you can see that. That's going to equal 0. And that's where x equals 10. Okay, then it's going to open upwards because of the 1/2. That doesn't even actually matter on this problem. Okay, but the axis of symmetry, it's going to be halfway in between the zeros, so it's going to be x equals, I'm going to average the x coordinates of the x-intercepts. So 10 plus -3 divided by 2, so that's x equals 7/2. Okay, or 3.5, whatever you want to call it. Okay, now we're going to write an equation for a quadratic function p of x that has x-intercepts here and there and a y-intercept at -72. I feel like we've done this problem already, but we can do it again. So p of x is going to equal some number a times x minus, I'll use x1 and x2 since I've got p of x. Okay, x1 is going to be 2 and x2 is going to be 12. Y-intercept -72. Okay, so when x equals 0, y equals -72. So I'm going to use that. I'll say 72 equals a times 0 minus 2 times 0 minus 12. So I've got 24a equals 72. Okay, I'm going to divide both sides by 24, and 72 divided by 24, that's going to be 3. Because 72 hours is 3 days. That's how I know that. And then, oh, whoops. I got to write my equation. Okay, it just said an equation. It didn't say standard form or anything. Had it said standard form, then I would distribute, I'd do FOIL, then multiply in the 3. Okay, now we're going to sketch the graph of one more. Okay, yeah, sure. This will be good practice for us. Let's make it a little bit bigger. Alright, so this is a parabola that's going to open down. And it's going to have intercepts at x equals, well, where x plus 4 equals 0 and where x plus 9 equals 0. So that would be x equaling -4 and x equaling -9. So that's going to be right here, -4 and -9. Okay, the axis of symmetry will be halfway in between those. So x will equal -4 minus 9 divided by 2. So x equals -13/2. Okay, that's kind of unfortunate, but okay, we can work with it. Okay, f is increasing when it's got a positive slope, or as I move left to right, the graph is going up. Okay, so that's when x is less than -13/2. F is decreasing where its graph has a negative slope, or where as I move left to right, the graph is going down. So that would be when x is bigger than -13/2. Okay, f has its maximum value at x equals -13/2. The maximum value of f is, well, f of -13/2, which is going to equal -5 times -13/2 plus 4, that would be 8/2, times x plus 9, that would be 18/2. So I've got -5 times -5/2 times +5/2, and 5 times 5 is 25. 5/4 is $1.25, so I know that 5 to the 3 is 125. And so this is going to be -125 divided by 4. Okay, and that was kind of some challenging arithmetic, but I think that was right at your level. Okay, that was number 20. That's got to be all of them, right? Yeah. All right, that's going to be all. I hope this helps. Thanks for watching.